Hello students, welcome to IMS GATE Academy. In today's session, 10 challenging questions of network. The subject is common for electrical, electronics and IN students. Every one of the question you try to do whenever I displayed on the board. This practice will make you to add some more knowledge. Understand my point now? Yes, I want to start my subject now. I will do the number of questions here now. The first question. Any student can do this question without my help. Is it possible to tackle this question without my help or not? You please check it. But what is given in this particular problem? In the given circuit of figure, if R1 equal to R2 equal to 0 ohm, then R equivalent across terminals AB is asking to find the resistance across this AB. But just by redrawing this circuit, we can get the resistance across AB. What way we can do? Please watch. I want to redraw this circuit like this now. But this point is given A. I wish to take this point as a capital A. This is a small a. This is capital B. This is capital C. This is a capital D. Like that I denoted letters. And the problem strictly given R1 equal to R2 equal to 0 ohm. When the resistances are 0, directly you can short like this now. I can redraw this diagram like this. Here I got 2 ohm resistor. This is the 2 ohm resistor. This is the small a. This is given small a. And also what we can do here now, the point A is given here. I will put that point A. Point A, whenever it is shorted here, if it is shorted this, R1 0 here now, R2 is 0 is given. We can short both like this. We can short. A and C are same points. We can combine. We don't have any resistor or something here now. No element is there now. B and D same here now. I will extend this line. This point I have taken as a what now? B and D I have taken like this. B comma D I want to take. Then after some other resistances we got it now, that we can see later now. But in between A and B we got 3 plus 2, 5 ohm. 3 plus 2, 5 ohms we are having here now. In between these two we got 3 resistances only now. In between A and B we got 3 plus 2, 5 ohm resistance. This is 5 ohm resistor we got here now. There is 5 ohm resistor. And also we can say between C and D there is 5 ohm resistance again. Between C and D means this is a C only. This point is a C only possible. C and D. There is one more resistor that can be taken as a 5 ohms here now. This is taken as a 5 ohm. And do you have any more means across this B and C? B and C. B and C means B and C, same points only. It reaches to same point. B and C, these 8 ohm and 8 ohm are in parallel. On simplification, it becomes 4 ohms. 8 ohm and 8 ohm becomes 4 ohms, you know. This 4 ohm is in series to 2 ohm and also series to 4 ohms. 4 plus 4, 8, 8 plus 2, 10 ohms possible now. That is the total resistance across B and C is there now here now. Okay, we can connect that point only now. This is a 4, this is a 2, we got now. I can write directly 4 plus 4, 8. I can write 10 ohms we are getting totally. This becomes 10 ohm resistor only now. This can be taken as a 10 ohm resistor. This is between B and C. Yes, B and C also that point. And again, if you extended the line, you will get here now, when you extend, simplify like this now, D is connected to the B point. D is connected to the B point. One more resistor. D is connected to B. This is with 3 ohm resistor. This is with 3 ohm resistor. There is one 3 ohm resistor only now. Now, I would like to find the total resistance across this AB. How we can find total resistance across AB? Resistance across AB I want 2 ohms. These 3 are in parallel, you simplify, and 3 and the resistor and 2 will be in series only. 2 ohms I am getting here. There is the 2 ohm we got here now. 5 and 5 parallel, it becomes a 2.5. 2.5 and 10 parallel, 2.5 into 10 by 2.5 plus 10, it becomes a 2 ohms only possible, I think now. 2 ohms plus 3 ohm here I got. The finally RAB equal to what is possible here? 3 plus 2, 5, 5 plus 2, 7 ohms here possible. 7 ohms possible now. The finally, which option is correct in this particular problem? Option B is right. Option B is correct only, we can say. Such a way we can tackle this question. I hope you followed. And I wish to give one more question. This is the next question. Any student can do this question without my help. Is it possible to do this question without my help? Anybody? How we can do? But what is given in this particular problem? What is asking in the problem? Find V2 by V1 for the following network. For the given network, the gain is required V2 by V1, where YL is given 1 by ZL. ZL is the load. The Y is the Y parameters are given. 4 options are given. Which option is correct is asking to find only now. V2 by V1 is required. But in this particular problem, what I want to do here is, what is V2 I wish to find at first, because my aim is to find V2 by V1. How to get V2 by V1? V2 equal to, I wish to note down here now. The load is, the load has to receive the current only now. With respect to load, if it is taken, current direction must be this side required. But current direction is given reverse. Current direction is reverse means with respect to voltage only. With respect to voltage, current direction we can take such a way only. Here I want to find the V2, but actual current must be this side towards the direction of the ZL. But it is away from the ZL it comes now. Minus I2 I can put. V2 equal to minus I2 into ZL I can write. That is the V2 value I can write. But what about this I2? If I ask the current I2 here, you can say V2 by minus V2 by ZL I can get. You know very well, YL equal to 1 by ZL equal to Y suffix L is given in the problem. That is the admittance. So V2 by 1 by minus V2 into, I can write as a YL. I can write Y suffix L I can write. This I want to keep it as an equation number 1. This I want to take it as an equation number 1. Next, what I wish to do is, what are the Y parameters? Y parameters I want to note down here now. What are the Y parameter equations? You know very well. I1 equal to Y11 into Y11 into V1 plus Y12 into V2, you know. What about I2 means, you know very well, Y21 into V1 plus Y22 into V2. That we know very well. That we know very well, into V2 will know. But thereby required, what value here required? I2, this is I1 and I2. Here the I2, capital I2 you have, but I2, this is a small I2 we can put it here now. Here we are using this small I2 only now. We can denote with a small I only now, because in the problem it is given small I. If it is given small I, we can use that best. Yes, we can use this small letter only now. In the question it is given small I 2. small I2 given, I2 we can put. This is also small I2. Why I have taken, because already I use here now I2, small I only now, same I2 I have taken here now. Here I want to use this equation, I want to substitute equation 1, I want to substitute in this second equation only now. If I substituted I2 value here, I2 is nothing but minus V2 into YL, no doubt. This is equal to Y21 into V1 plus Y22 into V2 I can write. Like that I can write now. Yes, we got an equation Y, YL we got now. This is YL, sorry. V2 into YL only now. V2 into YL. But here I want to take V1 in common. V1 in common I want to note down. If V2 is taken common, what I will get first of all? V2 equal to, I brought this V2 this side. So I will get Y22 plus YL I will get here now. YL I will get. This goes to this side, minus Y21 into V1 I can get. Y21 into V1. Finally, what ratio is required? V2 by V1 ratio is required as per the given problem. This ratio is required. So I can find what is V2 by V1 here. That equal to minus Y21 by Y22 plus YL. Y22 plus YL I am getting in this particular problem. That is the ratio. This is the required solution for this question. Which option is correct here now? From the given problem, minus Y21 where we are having minus Y21 divided by Y22 plus YL. Yes, option B is correct here now. Option B is correct in this particular problem. Such a way we can tackle this question now. And I wish to give one more question in your hand. This is the next question. Any student can do this question without my help? Anybody can do it? Anybody? In the given circuit, S is a single pole double throw switch. At t equal to 0, switch is thrown from C to B. C to B it is thrown. If capacitor was in its steady state at t equal to 0 minus, then what will be the value of IC0 plus? IC0 plus current is required here now. But how we can tackle this question means, you please watch. Initially, the switch is at the position of C. Initially, it is at the position of the C only. At the position of the C means total current is going to flow across this 4 ohm only now. It doesn't flow any current across the capacitor. No current is going to pass. At the time, IC0 minus becomes 0 amperes only. Because initially it is at the point of C only. Then after it is shifted to the B only now. If it is at the point of the C, the current passing through the capacitor is to be taken as a 0 only. I can write at t equal to 0 minus, at t equal to 0 minus, I can say IC of 0 minus is equal to 0 value only. IC of 0 minus 0 only. It doesn't flow any current. Now the switch is shifted to the what now point B at t equal to 0 plus. At t equal to 0 means this contact will be removed totally. This contact is removed. Thus total 10 ampere is going to flow this side only now. At the time this 10 amperes will pass, the capacitor can act as a short circuit at t equal to 0 plus. I can say at t equal to 0 plus, at t equal to 0 plus, there is no contact to the 4 ohm. The total current is diverting, 10 ampere is diverting across 4 ohms and 4 ohms only now. No current passes across this 4 ohm only now. These two are 4 ohms means what is going to happen now? This side current will be what now? 5 amperes is possible, and this side current will be possible 5 amperes only, because it is not diverting any current this side only now. The time I can write directly IC of 0 plus is nothing but IC of 0 plus is nothing but the 5 amperes only possible. Otherwise, you can apply the current divider formula. It comes same only now. Understand now. This is the solution for this question. And I will go to next question. This is the next question. This is one more good question. Any student can complete this question? What is given in this particular problem? For the given two-port network, Z parameters matrix will be given 4 options. Which option is right? We need to identify. Z matrix is must. But how this connection is there, you please watch. 1 ohm and 1 ohm, and this is one of the T network. The same current is going to flow this side. This is I1 means this is I2, I1 plus I2. This is I1, this is I2 again. Same I1 plus I2, I1 this side, I2 this side. So we can write here now 2 of the T networks are given here now. Just like a T network it is there now. Just like a T network we got here now. Shape just like that now. Anyhow, in this case, series interconnection we are having. This is connected in series to this only, series connection only now. When Z parameters are connected in series, we know very well, addition of the 2 Z parameters are to be made. Initially, you find the Z parameters of this network up to this extent you find. Then after Z parameters of these two, those two are connected in series only. At the time directly total Z parameter equal to ZA plus ZB. ZA is nothing but the of this network, ZB of this network. I wish to take what is ZA here at first. How we can write ZA? Very directly we can write now. If I selected this as a what now network, this current, what current will flow this side? I1 plus I2, no doubt. This I1, this I1 plus I2 possible. In the ZA, Z parameters of the first network, 1 I1, the KVL is applied this side, 1 I1 plus 1 into I1 plus I2 possible. 1 I1 plus 1 into I1 plus I2. That means 1 I1, this 1 I1, 2 I1, 2 is possible. Impedance parameters only. I2 quotient will be 1 only possible here. By applying the KVL in this path, I can find the what now? One more equation. When I go this side, 1 I2 plus 1 I1 plus I2. So I1 quotient is 1 possible, I2 quotient is possible, 1 plus 1, 2 is possible. Finally, I am getting ZA equal to 2, 1, 1, 2. And I wish to find what is ZB here. ZB also required in this particular problem. But in this case, I will apply the KVL in this particular path. Same I1 is going to flow this side. Same I2 will flow this side. This side is I2, this is I1, this is I1 plus I2 again. This side it is going to flow I1, this side it is going to flow I2 only now. If I apply the KVL in this particular path, this side is a 6 I1, 1 I1, 7, 7 plus 1, 8 I1 is possible. 8 I1 is possible. I1 quotient is to be taken as a Z parameter. And what about the I2 quotient? I2 quotient we can find 1 into I2, 1 only possible here. This is 1 only possible. What about the next equation? This side I will apply the KVL. If I apply it like this now, 1 I1 is possible here. And this side 3 plus 1, 4, 4 plus 1, 5. 5 I2 is possible. I can put here the 5. 5 possible. And Z equivalent is required. For the given network, Z parameters matrix is required. Z parameters matrix is to be taken as a ZA plus ZB. You can put directly. ZA plus ZB means 2 plus 8, 10 possible here. 1 plus 1, 2 possible here. 1 plus 1, 2 possible. 2 plus 5, 7 is possible. Finally, we are getting 10, 2, 2, 7. 10, 2, 2, 7. Option C is correct in this particular problem. That way, we can tackle this question. Followed? If there is any doubt, you can arise your question. Yes, I want to give one more question. Yes, this is one more problem. Any student can do this question without my help? Can you complete this question without my help? What is given in this particular problem? An AC circuit shown as below. The phasor voltage across 5 ohm resistor is given V volts. V volts. V is V as shown in figure. If V equal to A plus JB volts, that means voltage you are going to get this form. This form you bring this voltage A plus JB volts. The value of B by A is dash, is asking to find B by A. So how we can tackle this question? We need to find at first the voltage across this 5 ohm. If you want to find out the voltage across the 5 ohm, you need to get current passing through the 5 ohm. This current I want to denote by letter I1. The current which is passing through this side I want to denote by the symbol I2. The supply current you know very well I. The supply current is possible now. By using this we can start the work here now. How we can tackle this now? But in this case I wish to find what is I1 here. How we can find this I1? By using current divider formula. As per current division formula I can find I1 here. How I can get I1? Supply current into 5 at an angle of 30 degree. At an angle of 30 degree into opposite impedance. Opposite means 5 plus J3. 5 plus J3. 5 plus J3 divided by 5 plus J3 divided by 5 plus J3. 5 plus J3 plus 5 minus J3, total impedance. 5 minus J3 I can write here now. Such a way I got. On simplification I can get this I1 like this. 5 at an angle of 30 degree. 5 plus J3 divided by 5 plus J3 divided by here J3 cancel. I will get the 10. I will get here the 10 only now. This I am getting here now. The finally on simplification what answer I can get here now? This value will be in the polar form if it is taken this I1. In the polar form if you are using the calculator this value will be 2.915 at an angle of 60.96 possible here now. 2.9 that much degrees, 60.96 degrees possible. That much amount of the current is possible here now. That is I1. By using this I1 I can determine voltage V. The voltage equal to I will get like this now. Current into resistance 5 into I1 you know very well. The 5 into I1 is nothing but 2.915 at an angle of 60.96 degrees. Use calculator and finally you will get answer like this now. What answer is possible? 5 into this one. This value will be 14.575 at an angle of 60.96. That much voltage is possible. But we are getting the voltage in the polar form. But in the question what is given V is required in the form of A plus JB. If you are getting in the complex form like that, you will get B value, A value. Then you can divide B by A, you can find easily now. In the rectangular form, that voltage, polar form you convert into the rectangle. It comes as a 7.07075 plus J 12.74. 12.742 is possible. 12.74, that much value possible. Here the real part is given a name A. This real part is to be taken A. Imaginary part is to be taken as a B only now. But thereby required B by A value. I want B by A. B by A means I can put 12.742 divided by 7.075. If you are using calculator, finally you are going to get 1.8018, 1.8018, 8017, 1.8017, no units, B by A is a constant value. This is the solution for this question. I hope you followed. And I wish to give one more question here now. One more problem I want to give in your hand. Yes, can you try this question without my help? It's a one more good question from the network's theorems. Anybody can do this question without my help? Please try this question without my help. The Thévenin's equivalent resistance as seen by AB is dash. When the view is made from these two terminals, what is the total, what is the Thévenin's equivalent resistance is asking? We need to find the RTH value. The problem is given with independent and dependent source, both are existing here now. To find out any Thévenin's resistance value, wherever independent voltage source is given, that must be shorted, you know very well. You short circuit. And across AB, you can connect a voltage source or current source, one voltage source or one current source required. One test source we have to connect. That test source may be any one of the voltage, 1 volt or 2 volt or 3 volt or 4 volt or any voltage you can connect now. Because not to get any ratio values, to simplify the value very simple. The test voltage, I want to take it as a 12 voltage. 12 voltage means we will not get any decimal values. So decimal is not the problem. Okay, don't take, you take 1 voltage directly. Choice is yours, understand. But I have taken here now, the circuit I can draw like this now, first of all. Solution I can take it now. The circuit, how we get wherever the independent voltage source is given, that must be shorted. There is one 6 ohm resistor and 6 ohm resistor this side we got. This is one more 6 ohm resistor. And here the current passing through this 6 ohm is given as a 2I. This is given 2I. This is 6 ohm. There is one dependent source. That source is to be taken here. This current is given 4I. But I wish to connect a test source of the test source I have taken 12 voltage. I don't want 12 voltage, I will put 1 voltage or 2 voltage or 3 voltage. Choice is yours, I said now. Answer will be same only now. Why I selected 12 volts means not to allow any decimal value here now. The 12 voltage means same 12 voltage here now, same 12 voltage I can find. Same 12 voltage I can find. At the time we can avoid the ratio here. 12 by voltage by 6 current it comes. This current is nothing but 12 by 6, 2 amperes only possible. 6 ohms, this is also 6 ohms, this is also 2 amperes possible here now. This current also 2 amperes possible. 2I equal to 2 amperes means I equal to 1 ampere only. You know very well. I is nothing but 1 ampere. Why we need to find out the I means here the current source is given, that is a 4I. 4I onwards 4 into 1. I will get the 4 amperes only. This current is a 4 only possible. This current will be 4, I is a 1. Now we can apply the nodal analysis directly, but we need to find out the what value is required here now. Sorry, not nodal analysis now, but this current is required. Our aim is to find this current only. This current is required because, but in the problem what is asking Thévenin's equivalent resistance is required. Thévenin's resistance is nothing but Thévenin's voltage, this voltage source, test voltage source divided by current I. If I know the current I can determine RTH very easily. What way I can find this I? This current is divided through different paths. This current plus this current plus this current only now. So I can say the current I is nothing but summation of all the branch currents. We don't have any resistor in between these 2 points becomes a single point only. This side is a 4 amperes of current is passing this side 2 ampere, this is a 2 amperes plus 2 plus 2. That becomes 8 amperes of current is passing this side. Finally, we are getting I equal to 8 amperes. I can determine RTH like this now. RTH equal to 12 by 8. How we can find 8? 4 2s, 4 3s. 3 by 2 is nothing but 1.5 ohms possible now. So RTH equal to 1.5 ohms. Like that we can complete. I think you followed. And I wish to give one more good question. This is one more question. Any student can try this question without my help? Will you do this question without my help? You can try. In the circuit shown below, the current I flowing through 200 ohm resistor is dash milliampere. Is asking to find the current passing through this 200 ohm resistor. If you wish to find the current I, the current source transformation is better now. Here the current source is connected parallel to one resistor. By using the source transformation, we can simplify these networks. Then easily we can get answer now. I say this network I can redraw like this. I can redraw like this. 2 volts here connected, 2 volts here connected. In series to the what? 2 kilo ohms. Connected series to 2 kilo ohms. 2K I am putting 2 kilo ohms. 2K I got one more this side. This is 2K. This is 2K. And there is a current source 1 milliampere. This side 1 milliampere current source we are having 1 milliampere. And here the current source parallel to resistor. Somebody. No need to find small I sir. No need to find small I. Why we no need to find I? Yes, you can try the now. Okay, if you got in a different way, it is quite okay now. But this is one of the methodology to find out the value. This is one more methodology. Understand now. This is a 1 milliampere I got this side, and also this I will convert 1 milli and kilo cancel. It becomes a 1 voltage this side. This side I got 1 voltage. This side. This is 1 voltage. Connected series to the what now? 1K. I connected 1K. And 200 ohms I got here. I got here the 200 ohms. This is 200 ohms. This is 200 ohms. That you can determine easily now. We want current I this side. The current I is required. No need to find small I. Okay, this is the current is required here now. Current across this. But this how we can tackle this now? By using the nodal analysis, we can do this question. I selected this voltage as a V. You select that point as a V. Apply the nodal analysis, you will get answer. How we can do nodal analysis? V minus 2 divided by 2K means 2000, you know very well. Plus V by 2000 I can write here. V by 2000 I can write. This current is reverse minus 1 milli. 1 milli means 1 by 1000 I can write. 1 by 1000 I can write now. What about this current? V plus 1 divided by 1000 plus 200, 1200 I can get here now. That equal to 0 possibles. By using this equation, you can determine voltage V. You can determine voltage V here. If you are using the calculator, voltage V you will get as a 7 by 11 is possible. It comes as 7 by 11. By using this voltage, you can determine current I. This side it is passing. Current I is nothing but, how I can do, V plus 1 divided by 1200 we are having this side current. V plus 1 by 1200. You know V value 7 by 11 plus 1 by 1200 I can write now. Use calculator. that current is 1.36 milliamperes. 1.36 milliamperes possible. This is the current is possible from this network, I can say now. Understand now? Next one. But it is a DC circuit, sir. DC means okay that I equal to capital I you can put now, understand now. But given name small I, but exact means capital I you can put now under DC analysis now, understand. Next one, question number 8, I want to give one more. This is one more question. This is one of the simple question I hope you can do easily without my help. Start doing this question. You can start doing this question. Consider the circuit shown in the figure. The current I flowing through the 10 ohm resistor is asking to find the current through this 10 ohm resistor. It is given current I like this. Is asking to find the current across 10 ohm. In this particular network, what is going to happen is a very simple question here now. Because of the connection of this 3 voltage, current is going to flow this side and will be diverted this side. It is not forming any loop. This 10 ohm is not forming any loop. At the time, no current is going to divert across this 10 ohm. If the starting current is some current I1, same I1 will flow this side. Because of this supply, the current is going to flow this side and will go to this side. It is not a closed circuit only here now. At the time, it doesn't flow any current across 10 ohm. Directly, you can write current passing through 10 ohm, I equal to current passing through 10 ohm is nothing but 0 amperes only possible. That much amount of the current only possible here. That is the solution of this question. And next question I want to give in your hand. You please try this. This is one more good question. You please try this. I want answer from your side. Any student can do this question without my help. You please try to do this question. Anybody can do this question? Anybody? Is asking to find V. From the given below circuit, find voltage V. Is asking to find voltage V. To find the voltage V, here I want to apply the nodal analysis here now. This node voltage I wish to select as a V1. This node voltage I want to select as a V2. V2 is nothing but V only. Otherwise, directly you can put V, no problem. Directly you can put V also. V2 is nothing but V only. V2 equal to V only. V2 equal to V. Otherwise, directly V. I don't want that V2 sir. I will use only V sir. Very good. Don't. Who said no? We can take it also. Directly you can put V also. This one. V and V1. By using the nodal analysis, you can do this question. By using the nodal analysis, this current plus this current equal to 0. If I use node V1, if I selected this second node, the current directions I can put in this particular way. In this particular way, I can put. Then I can form the two nodal equations. By solving those two nodal equations, I can find voltage V. I selected this node at first. I want to apply the nodal analysis now. This current is minus 4 amperes reverse. Minus 4 amperes I am getting here now. This is minus 4. This current is nothing but V1 by 20. V1 by 20 I can write. V1 by 20. And this current is nothing but V1 minus V. V1 minus V minus of minus plus 60 divided by 10 possible here now. This is equal to 0 possibles. You take this as an equation number 1. From the given circuit, you know very well what is I1 here. The I1 is nothing but V1 by 20 here. V1 by 20 I can put here now. That is V1. And I wish to get the second equation by using this node V minus V1, V minus V1, V minus V1 minus 60 divided by how much? 10 ohms here possible by 10 plus this current is nothing but V by 30 I can write. V by 30 I can write. And this side current is nothing but minus of 0.4 minus 0.4 times of what? I1. I1 equal to here given V1 by 20. V1 by 20 directly I can put this is equal to 0. This I want to take it as an equation number 2. But you form two equations and solve them. If you are solving those two equations, you are going to get the V values. By solving this, you can get V value here directly. That V value is, you will get V value as, I will give now. The voltage V is minus 18.75 is possible. Minus 18.75 voltage possible. Minus 18.75 voltage possible. But that voltage we don't find in these 4 options here now. When you don't find that voltage, you can put as a none of this is correct. That voltage we are not finding in the option. So answer is none of them only now. That way we can tackle. Next problem. Can you tackle this question without my help? This is the 10th question, last and final problem. You can do. I hope you can do this last question. I want to give some time to start your work. You can try this question. What is given in this particular question? In the circuit shown below, the magnitude of imaginary part of current I is dash milliamperes. Current I is imaginary part of current I is required. That means when the current, you need to find the current. That current, if you got any imaginary what now coefficient, that is to be taken as a what now imaginary part of current I only now. How we can find this current I at first? By simplifying the network only now. Here delta connection is given. This delta connection you convert into the what now? Delta to star you convert here now. Delta to star if you connected, you can simplify these networks. After simplification, easily you can tackle this question now. I say this can be done by this method. There is voltage source. That voltage source I want to connect as a 14 at an angle 0 voltage only now. That much voltage. This side the current I is given in the problem. J4 ohms here, inductor you got J4, I got this, I want to take it as it is, J4 ohms. This side minus J4 ohms, this side I got, capacitor is there now, minus J4 ohms. But delta to star 666, if it is given, what value it comes? Delta to star you connect 2 ohms it is possible now. 2 ohms you are going to get now. The 2 ohms it comes like this. This is a 2 ohm, this is a 2 ohm, this is a 2 ohm is possible. I converted delta to star 2 ohms possible here now. That much value possible. But here, we can first of all we can measure the what we can find out the total impedance now. If I got the Z equivalent value, I can find I equal to V by Z only now. Z equivalent how I can get? These two are in parallel and series to 2 ohm. 2 plus J4 is in parallel. It is in parallel only here now. It is parallel with this impedance only. 2 minus J4 divided by 2 plus J4 plus 2 minus J4. 2 minus J4 I can write here now. 2 minus J4. 2 minus J4. and this total impedance is series to the what now? 2 ohms only here possible, in series to 2 ohms. Then I can find Z equivalent here directly. The 2 plus J for 2 minus J, A plus B, A minus B, A square is a 4, B square 4 square 16 minus J square is a minus plus 16 divided by J 4 cancel, I will get the 4 here plus 2. 20 by 4 here, I will get the 20 by 4 plus 2. 4 5s and 5 plus 2, 7 ohms I will get now. No angle, but no imaginary part. This is a 0 angle only possible. 7 at an angle of 0 only possible. Mostly that value. And I can determine the required value of the current. How I can find current I? The current I is calculated by V by voltage of 14 at an angle of 0 divided by total impedance I got 7 at an angle of 0 only now. And finally I am getting I2 plus 0j, J0 or 0j only possible in complex form. And we are getting the imaginary part of I. Imaginary part of I is nothing but the 0 only possible, 0 milliamperes only possible. Imaginary part of I equal to 0 milliamperes only possible. This is the solution for this question. I hope you followed. But all the number of 10 questions are done here clearly. Understand now. All are done here now. But I hope you followed so far. Thank you then.